Hello everyone. Welcome back to our software engineering series. In today's video, we will explore the Unit 4, covering some of the most important aspects of the software development like the project planning, the estimation, the scheduling, the risk management, monitoring and quality assistance or the quality assurance. These topics helps to ensure that the software projects are completed on time, within the budget, and at the highest possible quality. By the end of this video, you will have a clear understanding of how these processes work together to make a project successful. So let's get started, okay? So at first, the project planning, estimation and the scheduling. Project planning is a foundation of any successful software project. It involves defining the project scope, the objectives, and the resources. During this phase, the project managers create a roadmap that outlines the tasks, the timelines, and the deliverables. Estimation is a process of predicting the effort time and the cost required to complete the project. It's important to make accurate estimates to avoid the delays or the budget overruns. Scheduling involves organizing the project timeline and assigning the specific task to team members. This helps to ensure that the work is completed in a logical sequence with clear deadlines for each phase. Okay, so now risk management and monitoring. Risk management is a process of identifying, assessing, and mitigating the potential risk that could impact the project. Risk can include anything from the technical challenges to budget constraint or unexpected changes in the requirements. By anticipating this risk, project managers can develop the strategies to minimize their impact. Okay, so monitoring is the ongoing process of tracking the project's progress to ensure it stays on course. It stays on course. It involves regularly checking the performance against the project plan, identifying any issues, okay, early, and making necessary adjustment. Effective risk management and monitoring help to ensure the project is completed successfully, even when challenges arise. Okay, so now we will discuss about the software testing and techniques. So software testing is essential for the ensuring that the software behaves as expected and meets the user requirements. So software testing is a critical part of the development process. So testing can be done manually or with automated tools, and it typically involves checking for bugs, errors or other issues. Okay, so now we will discuss about the types of testings and discuss each type of testing of the software. So now manual testing. Manual testing involves human testers mainly interacting with the software to check for defects. It is used for exploratory testing, the usability testing when automation is not practical, like the black box testing. So types of manual testing has three types: black box, white box and exploratory. So black box testing, the testers checks the software functionality without knowing the internal working of the system. They focus on just input and expected outputs, just the external behavior, don't include in internal behaviors. But in white box testing, tester have full knowledge of the code and the architecture. They test internal structure like the code paths, the, the branches and the loops. Also, the exploratory testing, the tester explore the software without predefined test cases to discover the issues based on their own understanding and experience. Okay, so now the automated testing. The automated testing uses the tools and the scripts to run the tests automatically. It's highly efficient for repetitive and time consuming tasks, especially in the large projects also. So types of automated testing, there are three types, like the unit testing, integration testing, and the regression testing. Unit testing focuses on the individual units or the components of the software to ensure that each part works correctly. This is typically done by the developers, usually tools like the JUnit. Okay, it is a tools for unit testing. The integration testing test how different modules and or component work together. It ensures that integrated units function as expected when combined. Okay, so regression testing, after changes or updates are made to the software, regression tests checks that the new code has not introduced bugs in existing functionality. Okay, so some other testing like the function testings and the non-function testings. So function testing means it ensures the software behaves according to the specific requirements. Tester focus on the functionality of the software, including how it responds to the inputs and performs under the normal use. Means like techniques like smoke testing, sanity testing, user acceptance testing. Okay, so smoke testing means a quick set of tests to ensure the basic functionality works after a new build or the version is released. It is a simple check if it works approach, just like that. Check if it works. Sanity testing, a narrow focus on the specific areas of the functionality to verify that the new features or the bugs or fixes work as expected. Okay, so it is just like a narrow focus. User acceptance testing, like end user or client test the software to verify if it meets their needs and work in the real world scenarios. Okay, so non-functional testing. Non-functional testing evaluate the software performance, the reliability, the scalability, and the usability. This ensures that the software meets the technical standards beyond the basic functionality. So types of the non-functional testing like the performance testing, security testing, and the usability testing. Performance testing means measure the software speed, the stability, the scalability under the different workloads. It includes the stress and the load testing. Security testing ensures that the software is protected against the unauthorized access, the data breaches, and the other security threats. Usability testing, it checks how easy and intuitive the software is for the end users. It focuses on the user interface and the overall user experience, UI UX also. Okay, some techniques used in software testing like the equivalence partitioning, the boundary value analysis, the decision table testing. So this take like the equivalence partitioning testing, these techniques divides the input data into the valid and invalid classes. Test cases are designed to cover the each partition, reducing the total number of the test while still checking the key behaviors. We will discuss in depth in the mathematical portion also of the software engineering subject. The boundary value analysis. The test cases focus on the boundaries of the input ranges. We know that since the bugs often occur at the edges, so testing these boundaries ensures the critical scenarios are covered. Decision table testing. This testing use a table to model different decisions rules based on the inputs and the outputs. So test cases are generated to cover each rule or the decision path. Okay. So now the software quality assurance. So quality assurance is a broader process that focuses on the improving the overall quality of the software. QA or the quality assurance ensures that the development process itself is well organized and efficient, helping to prevent the problems before they occur. Together, testing and the software quality assurance help to deliver a product that is reliable, that is efficient also, and meets the needs of its users. Okay. So now that's wrap up of Unit 4, where we covered the project planning, the estimation, the scheduling, the risk management, monitoring, and the quality assurance. These processes are essential for managing the software projects effectively, ensuring they are completed on time and at a high level of quality. In our next video, we will dive deeper into different types of testing and the strategies to stay turned. So don't forget to like, subscribe, and hit the bell icon for notifications. Thanks for watching and see you in the next time. Okay.